Have you ever stared into the night sky and wondered what's really out there? Stars, planets, galaxies. But beyond them lies something far more terrifying and fascinating. Something that doesn't just bend the rules of the universe. It breaks them. Black holes. Invisible monsters in space that can swallow stars and possibly time itself. But what are they? Where do they come from? And could one be heading for us? Stay with me because the truth behind black holes is stranger and scarier than any science fiction you've ever heard. Hello, my curious fellows. Today we learn about the mystery of black holes. It all begins with a star, a giant, burning sphere of gas, millions of times larger than Earth. For most of its life, this star fights a delicate battle. Outward pressure from nuclear fusion pushes against the crushing pull of gravity. It's a perfect balance until the fuel runs out. When that happens, the balance shatters. The star can no longer hold itself up. Gravity takes over, fast and unforgiving. The core collapses inward in just seconds. Temperatures soar. Atoms are smashed. And then, boom, a supernova. One of the most violent explosions in the universe. It briefly outshines an entire galaxy. But in the heart of that chaos, something strange happens. What's left of the core gets crushed tighter and tighter. So tight that it doesn't become a planet or a dead star. It becomes something else. A black hole. A point of infinite density, wrapped in a boundary called the event horizon. It has no surface, no escape, no light. Space and time warp around it like a whirlpool. Anything that crosses the event horizon, stars, planets, even light itself, vanishes from the universe as we know it. There's no explosion, no warning, just silence and gravity. Unseen, unstoppable, and absolutely real. So, what exactly is a black hole? It's not a hole. It's not empty. It's an object, so small, yet so heavy, that it distorts the very fabric of reality. At its core lies the singularity, a single point where all the mass is crushed into infinite density. Physics can't describe what happens there. It's beyond human understanding. Surrounding the singularity is the event horizon, the invisible boundary where escape becomes impossible. Not because there's a wall, but because the gravity is so strong, nothing can move fast enough to break free. Imagine trying to climb out of a well, but the walls are infinitely steep, and every step pulls you further down. Even light, the fastest thing in the universe, can't outrun it. This is what makes a black hole black. It doesn't reflect. It doesn't glow. It just pulls endlessly. From far away, a black hole might appear silent, harmless even. But the space around it tells a different story. Matter caught in its pull spins faster and faster, forming a glowing accretion disk, a halo of superheated gas spiraling toward oblivion. Temperatures rise to millions of degrees. Radiation bursts into space. It's a feeding frenzy on a cosmic scale. And yet, the black hole itself remains hidden. Invisible. Untouchable. A shadow cast not by light, but by the absence of it. You might be wondering, if black holes are invisible, how do we even know they're out there? The truth is, we don't see black holes directly. We see what they do. Black holes leave behind a trail of destruction and energy. When a black hole pulls in matter, gas, dust, even entire stars, it doesn't happen quietly. That matter heats up, spinning at near-light speeds in the accretion disk, releasing powerful X-rays and radiation before vanishing forever. Telescopes like Chandra and XM Newton detect these high-energy emissions. It's like watching sparks fly just before something disappears into a shredder. Sometimes, stars are caught orbiting nothing. We see them wobble, speed up, or get slingshot around, clearly responding to an invisible force. That force is often a black hole. And in 2019, for the first time in history, we photographed the shadow of a black hole. Using a global network of telescopes, the Event Horizon Telescope gave us the now famous image, a glowing ring of light surrounding darkness itself. But black holes aren't all the same. There are stellar black holes, born from collapsed stars. There are supermassive black holes, millions to billions of times heavier than the Sun, sitting at the center of galaxies. And there may even be primordial black holes, tiny ones formed just after the Big Bang. Some we study, others we only theorize. But one thing is clear: they're everywhere. Some as large as our solar system, others small enough to fit on your hand, yet heavier than Mount Everest. Falling into a black hole isn't like falling into a pit. It's a one-way trip into the deepest mystery the universe has to offer. As you approach, things start to feel strange. Time slows down. Not metaphorically, literally. To an outside observer, you seem frozen near the edge, motionless, suspended. But from your point of view, you continue falling, accelerating faster and faster. You reach the event horizon, the point of no return. Cross it, and the universe erases you from its memory. There's no alarm, no flash, just silence. Then comes the most terrifying part: spaghettification. The black hole's gravity pulls on your feet more than your head. The difference in force is so extreme, your body stretches longer, until every atom is torn apart in a vertical line, like spaghetti. It's not science fiction. It's physics. You are no longer matter in any form we recognize. And at the end of this fall lies the singularity, the place where space and time crush into a single point, where the rules break, where information may be lost forever. No one knows what truly happens here, because no signal can escape to tell the tale. Once inside, you're gone. Not even light can tell your story. Some scientists believe time itself ends at the singularity. Others think the story might continue somewhere else. But that journey, if it exists, is still hidden from us, waiting to be understood. For decades, scientists believed black holes were eternal. Once they formed, they would remain forever, silent, unchanging, and indestructible. But in the 1970s, a single mind challenged everything. Stephen Hawking. Using quantum theory and Einstein's general relativity, Hawking made a stunning prediction: black holes aren't completely black. They emit something, a faint stream of energy, called Hawking radiation. Over time, this slow leak would cause a black hole to evaporate, to shrink, to disappear. But this revelation created a terrifying new question. If a black hole vanishes, what happens to everything it swallowed? Physics has a rule: information, whether it's light, atoms, or your DNA, can never be truly destroyed. It can change, but it must always exist somewhere. But black holes? They seem to erase it all. Stars, data, gone, with no trace, as if it never happened. This contradiction between quantum theory and gravity became known as the black hole information paradox. And it remains one of the greatest unsolved mysteries in all of science. If black holes truly destroy information, then everything we know about reality, about time, space, and the fundamental laws of the universe may be flawed. Some believe the information is stored at the event horizon. Others think it leaks out slowly with Hawking radiation. And some suggest we're missing something entirely, something big. But until we can look inside a black hole, the truth remains locked in darkness. What if black holes aren't just cosmic graveyards, but gateways? Some scientists believe they might be more than destructive engines. They could be portals, bridges through space and time. According to Einstein's theory of general relativity, a black hole's warped gravity could, in theory, create a wormhole, a shortcut between two distant parts of the universe. Enter through one black hole and exit through another, instantly, across thousands, maybe millions, of light years. But there's a catch. Wormholes, if they exist, would be unstable. They could collapse before anything, or anyone, makes it through. The tidal forces might tear you apart, or the laws of physics might rewrite themselves on the other side. The math allows it. Others go even further. They believe that when matter falls into a black hole, it doesn't get destroyed, it gets transferred. Not within our universe, but to another. A parallel universe. A cosmic recycling system, where the death of a star in one world becomes the birth of something new in another. These are not just wild theories. They're grounded in real physics, though far from proven. And yet, as we push deeper into the fabric of space-time, our understanding grows stranger with every step. Because black holes may be more than objects. They may be clues. Signals from the very edge of existence, hinting that the universe is far bigger and far weirder than we ever imagined. Black holes are not just cosmic mysteries, they're mirrors, reflecting the limits of what we know. They stretch our imagination, bend our science, and remind us how small and how curious we truly are. From the death of stars to the edge of time itself, they hold answers we've yet to uncover. And maybe, just maybe, within that darkness lies a new beginning. If this journey moved you, don't let it end here. Subscribe the Universal Knower for more untold wonders of the universe. Thumbs up, like, and speech balloon comment. What's your theory about what lies beyond the event horizon? We're only getting started.